Good afternoon, guys.
Good afternoon, sir.
Okay, so now we'll solve this question. Three battery A, B, C. Have they? We did this question before or no?
No, sir.
No.
Okay. So three batteries are there, and their negative terminals are connected. So how you can connect negative terminal of three battery in this way only, right? Can you connect negative terminal of all the battery when they are in series?
No.
No. So the batteries are connected in parallels. Between the positive terminal A and B, there is a resistance of 0.5 ohm. So can you see 0.5 ohm between battery number A and B? And between B and C, this is B, this is C, there is a resistance of how much? 0.3 ohm. Battery A voltage is 105, battery B voltage is 100, and battery C voltage is 95. Internal resistance is 0.25. Internal resistance of battery is 0.2 and C is 0.25. Determine the value of two resistor and power dissipated by them. Sorry, determine current value in the resistor. So you have to find the I1 and I2 and power dissipated by them. Clear the question? Question is clear? Can you solve this problem? Guys, do you remember the Kirchhoff law?
No, sir. I think in a junction, the current will be zero. It's like that. Sum of current will be zero.
So Kirchhoff law states what? How many Kirchhoff law is there?
Voltage law and current law.
Voltage law, of current law.
So what is what current law?
Current entering a junction equal to current leaving the junction.
Kirchhoff current law or Kirchhoff law states that total current entering into a junction in an electrical circuit is equal to the total current leaving. So if there are, this is the junction. So current entering I1, I2 is leaving, I3 is entering, I4 is, or maybe I4 also entering. All the sum will be equal to 0, right? The current entering the circuit and leaving the circuit will be 0, is equal. So obviously they will be 0. In other words, sum of the current entering a node is equal to the sum of the current leaving a node. So if you are going to do sum, they are equal. And what Kirchhoff's voltage law states? Kirchhoff voltage law states that the total voltage around any closed loop in an electrical circuit is equal to the sum of the voltage drop across the element. So if you can see, the sum of the voltage drop across this resistor, across this resistor, and the element in that loop. In other words, the algebraic sum of the voltage in a closed loop is 0. Clear?
So could you repeat one more time? In a closed loop is zero voltage.
I'll just post for you. KVL states that the total voltage around any closed loop in an electrical circuit is equal to the sum of the voltage drop across the element in that loop. In other words, the algebraic sum of all the voltage in the closed loop is 0. So summation of all the voltage in the loop will be 0. So
Okay.
you must be remembering we were calculating like this, right? I into 0.5. What current will be going in this line? I1 minus I2, right? Total current is I. So here 3 volt, these batteries are connected. Here current is I1, this is I2. So the remaining will be going here, right? So I1 minus I2. So if you are going to apply the Kirchhoff law in this circuit, you will be able to find the value of current I1 and I2. So for applying the Kirchhoff law in the circuit, so which terminal is coming here? This is positive terminal of the battery, right? So 100, or you can put it in the other direction also, it doesn't matter. So for understanding, because 105 is more, so we can take this direction also, okay? So when we are taking in this direction, positive terminal of the battery is coming first, 105, then negative terminal of the battery, then 100. This will be equal to all the voltage drop in the circuit, right? I1 into 0.5 plus I1 minus I2 into 0.2. And the other one is this one, 0.25 plus I1 into 0.25. Correct?
Sir, could you just tell me how did you take the sign?
Which
We are
sign?
summing the voltage, right?
Yeah.
Like 105, you take the positive and minus 100.
Yes. Just give me a moment.
Okay.
Okay, now you take this circuit on the left hand side, okay, and then we will be calculating in this direction. So when we are calculating in this direction, so can you tell me which terminal is here for the battery? Which terminal is here for the battery? Negative.
Negative terminal.
So write -105. Clear? -105 because negative terminal of battery is coming first. Okay.
Okay.
Then what value of the current is flowing from 0.25 resistor? I1.
I1.
I1 into 0.25. Correct? From 0.5 resistor, what value of the current is flowing? I1 again.
So, but sir, that we have to have plus or minus. The
Plus,
right?
plus. Only apart from voltage terminal, everything will be in plus.
Okay.
So plus I1 into 0.05, right? And we already discussed what current is going in the line, center line, I1 minus I2. Only
I1.
remaining current will go in the line, right?
Yes.
So plus I1 minus I2
Into 2.
into
0.2.
0.2. Then which terminal of the battery is coming? Positive terminal, right?
Yes.
Plus 100 is equal to 0, right?
One more is remaining. I2 0.3 is remaining. That is also plus.
No, we are only calculating on the left half, left closed loop right now.
Okay. Okay.
Okay. So you will get one equation for I1 and I2 from this side of the figure, correct?
I1 and
You will get some expression between I1 and I2, right?
sir, I2 we are not taking, right?
I2 we have taken, right?
Okay.
I1 minus
I1 minus
I2.
I2. Only we have to get the I1 minus I2.
I1 minus I2 we have taken, right?
Yes, yes.
Similarly, you apply this on the second side of the triangle, sorry, second side of the figure. So you will get two equation I1 from with I1 and I2, right?
Yes.
Can you now you are having two variable and two equation. Can you solve this equation? This is pure mathematics, right?
Yes.
So can you just show how to solve?
So from the left half, you got this figure. Sorry, this equation. From the right half, you got this equation. Can you solve both the equation and find out I1 and I2? You should be able to calculate, right? So just tell me what value of I1 and I2 you are getting. Guys, can you solve these two equation with two variable and two equation?
Hello?
Your value of I1 will come out to be 7.06 and I2 will be 8.55.
Sir, I have one more doubt.
Yes.
Like in this junction also, minus 100 plus 9, right side one. Right side
Okay,
one,
right side one.
minus 100 plus 95.
Just let me open this 1 second. Yes. Now
Okay,
tell.
and minus 100
Minus
then
100,
plus
correct?
90 plus 95.
Minus 100 plus 95, correct?
Yeah, then 0.2 into I1 minus I2, correct?
0.2 into I2 minus I1 now.
Sir, before we took I1 minus I2, but
Yeah,
here why you are taking I2 minus I1?
because when we are seeing from that side, it can be anything, right? I1 can be bigger than I2 or I2 can be bigger than I1.
But sir, why did we take before I1 minus I2? Here we are taking opposite.
In that case, we assume that value of I1 is more than I2. And when we are calculating from this side, we are assuming that value of I2 is bigger than I1.
Okay, so I2 minus I1 into 0.3 into I2,
0.3 into I2, correct?
then 0.25 into I2, correct?
0.25 into I2, yeah, correct.
Okay, okay.
Equation 105 is positive or negative?
105 is why it's showing positive here, because instead of writing equal to 0, they brought it to the other side of the equal to. What we write everything to the left side, right? And our right side was equal to 0, right? Both are same thing.
But if it is going from negative to positive, then it will be negative, no, 105.
How negative? What you have written minus 105, right? You have written in the first expression minus 105 plus I1 into 0.025 plus I1 into 0.05 plus I1 minus I2 into 0.2 plus 100, right? Equal to 0. We have written this.
Yes, sir.
So keep everything on the I1 and I2 on the left side, all I1, I2, and just move 105 and 100 to the other side of the equal to. So what will be, it will be same, what is written on the screen.
Yes, sir.
One 1.33.
1.33.
Yeah.
What is 1.33?
I1.
I1, I2.
No, I don't get. No, I correct or not?
As per this, it's showing 7.06 I1 and I2 8.55. I don't know these calculations are correct or not. Just calculate this equation I1 and you will find out value of I1 and I2. Then power is equal to what? I square R. Just put I square value for the resistor 0.5 and I square value for the resistor 0.3. You will get the power in both the resistor. That is what they are asking in the question. Current is I1 and I2 and power I square into R. I square into R. You will get the power dissipated by the resistors. Okay. Or you want me to solve the I1, I2 with you?
Can you just solve?
So I'm not getting the first equation fully. What's
You are
5
not
equal
getting.
to, I'm getting 5 equal to 0.95 minus 0.2 I2.
Just wait.
0.91
I'm
I1.
also solving. I thought you guys will solve. Then I didn't paid attention to the equation solving because this is pure mathematics, right?
Yes.
7.95. So first equation we will get like 0.95. If I'm wrong, then correct me. 0.95 I1 minus 0.2 I2 equal to 5, right? From the first equation.
Yes,
Correct?
correct. Yes, correct.
Okay. From second equation, we are getting minus 0.2 I1 plus 0.7 I75
7.5.
I2 equal to 5.
Yes,
Correct?
correct.
Now multiply equation number 1 with
Second equation, please repeat one more time.
0.2 I2
Minus, minus
minus
0.2.
0.1 I1 plus 0.75 I2 equal to 5. Okay. Now multiply equation number 1 with 0.2. Multiply equation number 1 with 0.2. Okay. And multiply equation number 2 with 0.95. And then add both the equation. So we will get like When we will multiply equation number 1 with 0.95, you will get what? What is the value of I1? 0.95 into 2 is how much? 0.95 multiplied by 0.9.2. 0.19 I1, right? I1 plus 0. Plus 0.04 I2 equal to how much? 5 into 0.2. Equal to 1. This will be our equation number 3. Okay. Then in the second equation, if we are multiplying 0.2 with again with 0.95, we will get minus 0.19 I1 plus 0.75 multiplied by 0.95. 0.712 or 0.713 I2 equal to 4.75. This is our equation number 4. Then just add equation number 3 and 4. On adding equation number 3 and 4, you will get 0.04 plus 0.713. That will be equal to 0.753 I2 plus 5.75. So I2 will be equal to 5.75 divided by 0.753. Your I2 will be equal to 7.82. Correct? I2 will be equal to 7.82. Just put the value of I2 in any equation, you will get a value of I1, right?
Yes.
So just calculate the value of I1. Just put in the equation number 1, 0.95 into I1, 0.2 into 7.82 equal to 5. 0.95 I1 equal to 5 plus 0.2 multiplied by 7.82 plus 1.56. So it will be total 6.56. 6.56 divided by 0.9.5. 6.56 divided by 0.95. You will get a value of I1 equal to 6.90. Okay.
Sir, when we add, we will get I2 equal to 18.4, correct?
How much you got I2 when you add?
18.4.
18.4. How?
Yes. Equation number 3 and 4 I am adding. So
Okay,
one plus,
you are adding equation number 3 and 4. So I1 will be 0, right? I1 will be cut by I1, right?
yeah, I1 will be cut.
Yeah.
Then 1 plus 4.75, that is 5.75.
1 plus, yeah.
0.4 plus 0.7.
0.04, right?
0.
We multiplied top equation with 0.2. So 0.2 multiplied by 0.2 is how much? 0.04, not 0.4.
Okay.
This is pure mathematics, guys. You should know at least all this.
Okay. Okay, I got mistake.
So you can just do I square R, right? Clear this question? I1 will be 6.90, I2 will be 7.82. Okay. Clear, guys?
Sir, last part I want to see one more time. Last part.
Don't, these calculations are not correct. Okay. But you want to see formula for power?
Yes. I2, I1 found out.
I2, I1 what?
I2 equal to 8.55. I1,
You got I2 like 8.55. How much you got actually? I'm telling you, this might be wrong.
7.9. I got 7.9.
I2 7.82. It's okay. 7.9. You must have taken maybe the value of this I1 maybe longer. 0.7125 full, right?
Okay.
So that's why our answers are
Okay.
different.
So I'm just writing the same answer, 8.55. I1 how much? 7.06.
Yeah, just check again whether these calculations are correct or not. Okay.
Okay. Then power in 0.5 ohm resistor.
Yeah, that they are asking in question, right? What is the power in 0.5 ohm resistor?
So P equal to VI.
I square R. Power equal to P equal to
I square
VI.
R.
Power is equal to I square R, right?
Yes. 0.4.
Okay, even if you are saying power equal to VI, then what is V is equal to IR? Again, I square R. Correct?
Yes. Sir.
Even if you are doing with the VI.
Okay.
Clear? This is a small question. I think you should be able to do on your own. Calculate the current in each branch and total current. Okay, we'll do this question later on. Then again, you will be having some confusion. We'll do some other question. Then we will do this one tomorrow. This will take time. Just see if you can do this question. If you can solve. A 18.65 kilowatt, 4 pole. So what is 18.65? What is 18.65?
True power.
Sorry, what? Power,
True.
right?
Yes.
So 18.65 kilowatt is power, 4 pole, 50 hertz frequency. 3-phase induction motor has friction and windage losses of 2.5% of the output. So how much is the output? What is the output?
97.5%.
No. Okay,
No.
that you already. What is the actual output I'm getting from the motor? How many kilowatt?
18.65 kilowatt.
18.65 kilowatt. So can you calculate 2.5% of 18.65 kilowatt? How much it will be? For 66 kilowatt. Sorry, 466 watt, right?
Zero point 46.
456.
0.46, right?
Yeah, 0.466 kilowatt. Okay. So next they are saying the full load slip is 4%. Okay. Full load slip is 4%. Compute for full load. A, rotor copper loss. B, rotor input. C, shaft torque. D, gross magnetic torque. So we have to calculate rotor copper loss, rotor input, shaft torque, and gross magnetic torque. So losses are how much? For 66 watt. Guys, I think better we should solve this problem tomorrow. This is again going to take some time. So we will complete this problem tomorrow. Try to solve on your own if you can solve. Otherwise, we will discuss the solution tomorrow morning.
So is there any solution for this problem? What is the solution?
Right now, I don't have the ready-made solution. Okay. See you in the next class. Try to solve if you can solve. Otherwise, we will discuss tomorrow morning. And if any of you can solve this problem, you can put in the group. Okay. So that other can also refer. Okay. Okay, guys. Thank you for your time.
Thank you, sir.
Okay, sir.